An inner join, also called a natural join, is the intersection between two data sets. In other words, it's the information that's common between both data sets. The join happens inside the from clause, so the syntax is from the first data set, and then inner join data set number 2 on, and then you define the condition or what's common between the two data sets. The word inner is actually optional, so if you just say from table, join table, it's assumed to be an inner join. So let's look at a join in action in code. We're going to use the CHA2 database. And talking through the query using the logical progression of the query, we'll start with the from clause. So this from clause looks at the tour table and the Basecamp table and finds where the tour Basecamp ID is equal to the Basecamp ID in Basecamp. And this is the way that it will merge together the rows. It can seem to have a multiplying effect because if there are 3 tours for one Basecamp, the Basecamp will be listed 3 times, once for each tour. So as it matches together tours and Basecamps where they share the same Basecamp ID, rows may be duplicated or eliminated. For example, if there is a Basecamp with no tour, it's not going to be listed here in this inner join. The inner join is only going to return those where there is a match between tour and Basecamp. So let's execute the query. And in the columns that are returned, the first 2 columns come from tour. It's tour name and tour Basecamp ID. Column 3 and 4 come from Basecamp, and you can see that the Basecamp ID does get matched between them. This syntax is known as the ANSI style joins, and it's the recommended way for doing joins. I prefer it because this way the on condition is listed right there in the join clause, so it's easy to see the on condition. There is an older style way of doing joins, referred to as the legacy style join, and this is the exact same query written in a legacy style join. Here in the from clause, the tables are listed out in a comma delimited style, and the condition that joins them together is simply listed in the where clause. Developers with an Oracle background have a tendency to write legacy-style joins. Very complex legacy-style joins are difficult to read because the where clause includes both join conditions and where conditions, all put together into one very complex where clause. It makes it more difficult to maintain and understand these joins. Another reason why these are poor joins to do is that in SQL Server 2005, the left outer and right outer version of this legacy style join has been deprecated. It's no longer working. And in future versions of SQL Server, Microsoft has already publicly stated their intention to do away with legacy style joins. So I advise against them. Just to demonstrate that SQL Server is a declarative query optimizer, I'm going to go ahead and execute both of them and look at the query execution plan just to show you that they are identical. First, I'll remove the result pane and turn on Show Execution Plan. Select both of these, execute. Open this up. And indeed, both queries have the same execution plan. So here's a more complex, more real-world version of a join. Let me remove the result pane, and let's walk through this one. Beginning in the from clause, it'll look at the contact table, and then join from contact table over to the order table. That's the first 2 tables. From the order table, it can connect using the order ID down to the order detail table. The order detail table has the product table, so from order detail product ID, jumping over to product ID, we connect the product table. We've now seen 1, 2, 3, 4 tables. Then the 5th table is from product up to product category, connecting on product category ID. Then there's a restriction where only product categories of kites are included. Continuing through the logical progression of the query, we select out last name, first name, those both come from the contact table, and then product name from the product table. And then the final step is that it is ordered by last name and first name, and there are no predicates. Since we're joining 5 tables, let's look at this in the graphical query designer as well. First, switch over to OBX Kites, execute, and then select the entire query. Open up the query designer, and let's give us some more room and rearrange this. Contact joins to order, joins to order detail, over to product, and up to product category. And then as we highlight through, we can see the inner join conditions and the whole code here. So very nice. Execute this. And then since we have the execution plan already there, let's look at this as well. We can see the physical order of the execution. And zoom out, zoom out. I know this is too small to read. We're just going to walk through this anyways. Physically, I decided to begin at the product table and do an index seek on product category to find the ones that are only kites, and then join that together, which selects out then only those products which are kites. Then this is the order detail table, which it joins together. It did an index seek to find the correct orders, and then is doing a RID lookup to find the rest of the data for the orders. Then here's an index seek for the contacts, a clustered index seek to go find the rest of the information about the contacts. Finally, here's the sort, and then the select. So this illustrates the fact that the way we place the joins is not at all the way that it actually executed the joins, which is a good thing. We want the query optimizer to figure out the fastest way to execute the query, regardless of how we actually stated the query.